Okay, so yeah, thank you for coming. I'm going to need to go quite fast because I managed to use up 8 minutes of that. 8 minutes in that way. So we're back to, it's Return to Planet Collections. First, a word or two about me, just the usual stuff. This is who I am. I've written a couple of books I wrote a book about Java 5, big update to Java, and then a book about Java 8, big update to Java, and I'm a member of various community programs, and I speak at a lot of conferences. I'm an organizer. I'm one of the people behind something we're calling the Unconference Alliance, the Java Unconference Alliance, that I want to promote to you. Unconferences are this great idea. Here's pictures of people at unconferences. So, like, we enjoy ourselves at unconferences. It doesn't mean we don't get any work done, because we get work done and we socialize as well. And it's a great combination. So you may have heard of JCrete, which was the first unconference, and there are others now as well. I run JALBA. You can find out about the Unconference Alliance there and apply to a number of them, and one that you can apply to is JALBA, although it won't be along for another year because you just missed it last week. So that was a mistake on your part. But the people who came really enjoyed it, and I would recommend it. Obviously, I would. So I wanted to look for something that would show the first book that I wrote, the Java Generics, co-wrote, the Java Generics and Collections book. I wanted to show that in a good light, and I was trying to find something that looked a bit more like antiquated and decrepit than that book does. So this is the Antikythera mechanism, and it's just there because it's like the oldest computer ever. Nobody knew that the Greeks could make computers, but they did, it seems. And it makes my book on the Java 5 book look quite modern, really, by comparison, even though it's a bit faded. It's faded enough that I thought, since they could kind of smarten up the Antikythera mechanism, this is a digital reconstruction of it, I thought, well, okay, so maybe I can do the same thing with the book on generics and collections. And it's coming into a new edition now, and I'm here to talk about some of the stuff that I've been looking at for the Collections API, which has changed a bit in the last 15 years. Perhaps not quite as much as you think, but perhaps more than you think, I guess. So we'll have a look at that during the talk. And in order to kind of, because I know everybody here knows about the Collections API, I thought, how can I make this look a little bit novel? And so my idea was, you know, since nobody here is a junior developer or an intern, but you know, sometimes we do have junior developers and interns that we have to mentor, and these people can be very, very annoying. And so let me introduce Audrey. I've asked Audrey to be as annoying as possible today, in order to sort of channel the kinds of difficulties you're going to make. Well, she's French, so it's probably not going to be much of a problem for her to
natural skill in there. So, you see, Maurice, there is this thing. I want a list, okay? Pretty simple list. Just want to put 3 elements in there. So, I really don't get why I need to bother to type this, because I've been told good developers are lazy developers. I don't want to type all of this. When I can simply use this. Looks like it worked pretty well, right? But then, I wanted to add another element, and I got this unsupported operation exception. Seriously, what the fuck?
See, she's doing quite a good job, don't you think? I mean, I'm certainly quite annoyed about that. Why are we getting unsupported operation exception here? Well, I mean, you know the answer, but if you want to explain it to Audrey, then you've got to think, what is it that arrays.aslist is doing? Right? I mean, it would look like a nice way of doing it. And actually, I mean, if Audrey had the patience to stop and listen to me, I would explain how you can get something as concise as that using streams nowadays. But I'm not talking about streams here. I'm talking about collections. So what you get back from arrays.aslist is a list. I mean, that assignment there is absolutely well typed. It's not a problem. So the list that you get there is an implementation of Java util list. But it's not an array list, obviously. It's something called, it's an inner class of the Java util arrays class. It's called Java util arrays array list. And what it actually does is it's like a window into an array. So the varargs argument to asList wraps up the elements into an array, and what you see there, you're seeing a list, but really what's going on is you're seeing the elements of the array behind there. And so it's kind of obvious as a result of that. It's kind of obvious why it is that you can't add a new element to it. You can do some things, like you can set elements and you can change the values, because you can change the values in an array. You can read them, but you can't do anything that you couldn't do with the array. So it's kind of obvious why that's failing. So you might well say, well, what's the point of the view? And the answer is, well, there's lots of useful methods on the list interface which you still can use. So you can ask whether something is contained in it. You can iterate over it in a nice way, and so on. But there's going to be bits of the list interface that you can't use, and that's typical of views. And so there are a lot of views in the Collections API. An example of another one. So this is abstractly, this is what a view is. You can this particular view. You think you've got a list of E, and you have, but the backing structure is an array of E, and that's going to limit what you can do. One other example of a view of this kind is if you've got a map. So a map of K and V, you can look on that as a set of KV entries, and the red and black things in the picture are, each one of those is an entry, a map.entry, containing a key value and a value. So you can call the method map key set, and that will give you a view of the map seen as a set of keys. So again, got the same thing. What you see is a set. But what you're actually, if you looked through it, you would see that you're looking at a set of key value pairs. And again, the restrictions on that are going to be kind of obvious. You can remove something from that set, and if you remove it from the set, then you're going to remove it from the backing map. But you can't add something to that set, because what would be the value that would be associated with one that you're adding? So the upshot is, these views, which are very useful, are going to be quite limited in various ways. Some of them are completely transparent, like, for example, sublist is a sublist of a list. You can do anything with that you could do with the backing list. And the same is true of headset and tailset on navigable sets. But some of them are quite restricted. At an extreme of restriction is something like the collections. The unmodifiable wrappers in the collections class, which prevent you from doing anything other than reading from a collection. So this idea of views is I think pretty useful, and it's kind of natural that you would get restrictions along with it. Does that satisfy you, Audrey?
No, it doesn't.
No, well, it wouldn't, would it?
No, because, I mean,
I don't
know if you remember the other day we had this quite bothering discussion about the substitution principle. Like, you were like, wherever value of type T is expected, you can provide a value of a subtype of T instead. Okay, this in a class is a subtype of T. Why can't I use it as a class, as a list? I mean, I'm getting unsupported operation exception. What the fuck?
Well, good, eh? So the idea is, if it's a list, I mean, what does this mean about specification? People often ask this question. I mean, there's a big pushback against unsupported operation exception. So, like, why do we put up with it? Why are there these optional operations? This is the Java doc for the add method on list. So you can't read it, so I've blown a bit of it up. The actual spec itself. It says appends a specified element to the end of this list, and it's an optional operation. So optional operations, so lists that support this operation can place limitations on what elements that can be added to the list, and a list class should clearly state what what the restrictions are in the documentation. Well, there is no public documentation on that in a class, array list, inside of the arrays class. But the method as list actually documents that you're going to get an unmodifiable list back. So people say, well, like, what about, what's this got to do with the substitution principle? Well, the unfortunate answer is that the substitution principle, well, it's not unfortunate, really. Really what people are saying when they complain about that is, I don't like the spec. The spec says this operation may fail, well, throw an exception, and you don't want that to happen because, you actually want you want the interface, knowing that you're programming to the interface, you want to be confident that the method you call will actually work. And the spec says, well, it might not. So yeah, the implementers have faithfully implemented the spec. Maybe the spec's no good. Right? Why don't we have an interface that actually says that you can't do these operations? Does that answer your question, Audrey?
Yeah, kind of, but actually, there is something else I would like to do, and I'm very, very annoyed that I can't do it.
No, I think you're using the wrong word here. It's not annoyed, annoying.
Well, the thing is, I would like to be the cool kid in town, and I would like to use some immutable list. Why can't I use immutable list? I mean, Eclipse collection got them. Guava collections get them, Kotlin get them. I want to do some Kotlin. Come on.
Yeah, Kotlin's very cool, isn't it? I mean, Kotlin's a lot more cool than Java. Yeah, absolutely. So, what about these classes? All of these APIs all seem to manage to have immutability in the interface. Well, not necessarily in the interface, as we'll see, but they have immutability in the type structure. Why can't Java have immutability in the type structure? This seems like unreasonable. Or it seems unreasonably, imprecise or something. So let's just look at these very briefly. Guava collections, for example. Guava immutable types. Guava does have these immutable types, and they're probably the nearest thing to actually being immutable of anything that we're going to see. So they're actually classes. They're not interfaces. But the Guava spec says very clearly, never mind that it's a class. We only made it, effectively, we only made it a class because we didn't have sealed interfaces. And if we want something to be genuinely immutable, with air quotes, if we want it to be genuinely immutable, then we want to make sure that nobody's really going to be able to mutate it. And that means that they can't pass you something of this type and still mutate it under the covers. In other words, they can't upcast it to being an immutable collection. If it's a mutable subtype, they can't upcast it to being an immutable collection and give it to you on the basis that you'll then think, oh, right, this can't be mutated. Well, by preventing them from being subclassed, they just make the constructor package private or protected, I guess, protected. Then they can't be subclassed, and they are genuinely immutable-ish. Because when we talk about immutability, we're not really talking about immutability in the kind of sense that would make things, for instance, thread safe. To be genuinely immutable, you've got to not only prevent modification of the reference that's held in the collection, which is what people usually mean by immutability. Sometimes they call that shallow immutability. But shallow immutability is kind of confusing concept because immutability means you really, really can't change anything in it at all. And that means that if the reference in the collection points to an object graph, it might be quite a big thing, everything in that has to also be immutable. Otherwise, there's always the possibility of destructive thread interference. It's not safe for concurrent programming. So Java talks about that kind of shallow immutability as unmodifiability. And it's all that we really can achieve in object-oriented language. It's extremely difficult to implement a genuinely immutable data structure. So I talk about this a bit in a talk called Change. Is change the only constant? You can find it on YouTube because it's actually really quite a complicated question. These things don't solve Audrey's problem. They are genuinely immutable, but they inherit from Java util collection, so they've got the immutator methods on them. You're not going to be happy with that. I know it says immutable in the title, Audrey, but it's still going to throw an unsupported operation exception. How about Eclipse? Now, Eclipse has a different approach. So Eclipse has things that it calls immutable collections. And again, it's the same story, by the way. Whenever these guys talk about immutability, they're always talking about what we call unmodifiability in practice. Nobody has a way of ensuring that an entire object graph is really immutable. So Eclipse Collections has a complete parallel hierarchy of the enormous, fantastically ramified library of different types, and for every type they've got an immutable type, and they've got a mutable type. And in this case, of course, the immutable collections don't inherit from Java util collection, so they don't necessarily have the mutator methods on them. But in fact, of course, you can subclass from these, and you can still pass somebody something which has the type of an immutable collection, but is a subclass that actually can be mutated. So you've got to think about, like, what is your intention here? If you use immutable collection as the type of a collection, what are you trying to communicate to? I mean, if you're a library programmer, and you want to be passed an immutable collection from a client, what are you trying to really achieve? I mean, it could be that you're trying to communicate a design goal. I really want this thing to be immutable. Or you could be trying to achieve security. I really need this thing to be immutable. And there's a big difference between those. And most of the time, with Eclipse collections, for example, it's design intent that you're meaning to convey. Now, I'm not here to sort of say Eclipse collection's bad, Java collection's good. I wouldn't say that at all. But there's a very different approach. The consequence of this, with other things, to be fair, other things about the Eclipse collections, means that you end up with, by my count, roughly about 3,000 types in the API. And even I think Guava has like hundreds of types in the API. So actually trying to allow for trying to allow for immutability is going to lead to a real proliferation of the types in the interface. And one of the intentions, I mean, you couldn't use Eclipse collections without an IDE in effect. Nobody's going to learn those 3,000 types. But the idea of the Java collections framework is that you're going to be able to learn it. Even Audrey is going to be able to learn it in the end when she's kind of less interested in kind of complaining and more interested in just getting down to doing some work. So last of all, Kotlin. So Kotlin has these has collections which are actually the nearest to what Audrey wants. There's a collection type. They're not tied to the Java util libraries at all. There's a collection type which doesn't have mutator methods on it, so it's read-only in inverted commas, and there's a parallel set of interfaces for that are read-only, like set and list, and then a mutable collection is the interface that has mutator methods on it, and then a mutable list, for example, inherits from a list and from a mutable collection. So this is kind of the nearest to what Audrey wants, but it's still not actually. I mean, these things are not immutable because, again, you can subclass. Well, you can actually just implement the mutable the list interface with an implementation that's actually mutable. So it doesn't provide security. Again, it's design intention. And interestingly enough, there's a proposal in the Kotlin community to actually introduce immutable types. I mean, really immutable types, or rather really unmodifiable types, as we would say in Java. So you might not like. So my question to Audrey is going to be: okay, you say you want immutability. Well, which of these three would you like, Audrey? Have you really thought out the issues and the pros and cons and weighed the possibilities? This is a kind of standard lesson. People say, "Hey, this would be a good idea," and the Java designers say, "Yeah, but have you actually really thought about this? I really thought about it. Have you worked through all the consequences? Have you produced a prototype that's going to show how it'll work?" And by and large, it's kind of a lot easier to just complain about things. so, so the net effect, and this is really quite a strong principle of Java generally, but of the Collections API in particular. It was designed because to appeal to a very broad audience. The idea was we're going to have millions of Java programmers, and we now have millions of Java programmers all over the world. They're not going to learn a really big API. So they kept it simple. Now, are you satisfied?
Kind of, but can you really show me what you're calling simple in there?
You show them.
Thank you. Is that really what you're calling simple? Oh, nothing to add in there. Let's do it.
Let me explain. So actually, when Java first got off the ground, the original Java Collections API was really very simple. It looked like this. This was all the interfaces that were in Java 2, 1998. I remember it well. And the problem with this is, I mean, it did really well. I mean, Java really took off with the Collections API, which looked like this. But clearly, not really enough, and particularly not enough if what you want is to support concurrency. So I'm not going to go into this here, but the implementations, the ones that we use every day still, the same ones that came in Java 2, ArrayList and HashSet and so on, were designed not to be thread safe. That was a specific decision which reversed the policy of the legacy collections which were in Java 1.0 and 1.1. And the reason was because they figured that most people didn't need thread safety, but everybody was having to pay for it through these thread-safe collections, vector and hash table, and so on. So that they were very inefficient, and they thought very reasonably, it was not a decision I would question at all, that they should make the new ones non-thread safe. So they have things called synchronized wrappers, which are kind of allow you interoperability with the current collection. So there's interoperability between a wrapped array list and an unwrapped array list, but they aren't very efficient at all. And so because concurrent programming was kind of coming up to the fore very much by the time of Java 5, they introduced two and a half new interfaces. Concurrent map, which was specifically designed for, this was really the most important one, specifically designed for multiple thread access, and blocking queue, which was designed for workflow scenarios, where you've got producer processes and consumer processes, and you want to be able to make sure that they're going to be able to that a consumer process will block when it can't get an element, and a producer process will block when the queue is full because it's working as a buffer. And then on top of the blocking queue interface, they introduced a queue interface for non-thread safe implementations, and that's how things stayed. So Java 6 still on the same kind of principle of looking at workflow scenarios. They introduced something called DEC, and an enhanced sorted set as well, the sorted things. So DEC is a workflow thing. It's a double-ended queue. It does everything a queue can do, but it's symmetric at both ends. And it was first of all introduced for work stealing scenarios in workflow situations. But the navigable set and navigable map were introduced because they've got some enhancements. They allow you to find a value in the set or the map which is adjacent to a target. Actually, they're really nice interfaces, and nobody ever uses them. In my experience, I always try and big them up. So that was the situation in Java 6. And then nothing happened for a really, really long time until Java 21, which is like next week. It feels like next week to me because that's the deadline on my book. But it's actually a couple of months away still. JEP 431 introduces the idea of sequence collections. So this may be something that's new to you. The thing that's lacking from this picture is there's an abstraction missing from this picture, which is the idea. Well, the idea of a sequence collection. It's to do with something called encounter order. Some of these things have got encounter order, and some don't have encounter order. Let me have a look. Let's have a look at this next slide. An encounter order is something that a collection that has encounter order has a strict total ordering on all its elements. So that's quite a well-defined idea. It means that every element is either less than or greater than all the other elements. So there's a strict order, and no two elements are incomparable. And in addition, every element except the first has a successor, and every element except the last has a predecessor. And what this means is that there are certain operations that anything with an encounter order ought to be able to support. And those things include like being able to add, remove, and inspect elements at the beginning of that ordering, and at the end of the ordering, equally. And it should be possible, if you've got if the ordering can be reversed, to be able to iterate and inspect the collection in reverse. So this idea of a sequence collection seems quite simple when you first meet it, but you've seen the effect it has on the diagram. Collections with encounter order can be internally or externally ordered. So a collection that's internally ordered has a comparator, or it's got a natural order on its elements, and it's quite easy to figure out what's going on there, because it's easy to mathematically define that ordering. It's a bit more tough for externally ordered collections, like Liszt, for example. There is a strict total ordering on Liszt, but it's the order in which they're actually spatially placed in the list, and you can alter it. So that's why I like this idea of external ordering. Like, you can reach in and change the order, whereas with a sorted set or a navigable set, you can't do that. When you add an element to it, it'll just go to the right place, and you can't do anything about that. So the collections that have an encounter order are these: list deck, sorted set, navigable set, and linked hash set, and linked hash map. Sorry, linked hash map should be in there as well. And you can see, if you think back to the diagram, or maybe think forward to the diagram that we just had. Well, let's think back to it. You see that these things are actually scattered around the hierarchy. There's no place in the hierarchy that unites them. And the result of that is that you've got this situation where there's these different collections were evolved at different times, and they've got different operations to be able to handle their encounter order. So they can be inconsistent, they've got inconsistent names, they've got inconsistent policies about what happens if they fail, and sometimes they're just missing. In particular, processing elements in reverse order is between difficult and impossible. So, in terms of the missing operation, there is no operation to look at the last element in a list. Well, it's not all that difficult. You just get the size of the list, you subtract one from it, and you index into that. But there isn't an operation to do it, and the abstraction is missing. The processing elements in reverse order, say from a linked hash set, is just impossible. Basically, you just can't do it. I mean, there is an order. The linked hash set and the linked hash map do maintain their elements in order, but you can't get at them. Well, you haven't been able to get at them before JEP 431. So the idea is that we're going to bring together all of these disparate collections and try and surface this abstraction, which has been missing until now. So that's what it was before JEP 431, and JEP 431 does that. So it adds in 3 new interfaces: sequence set, sequence collection, and sequenced map. And in addition, and so far, there's now an innovation which has never been in the Collections API before. We've always been able to draw a diagram like this, which connected the different interfaces. And then you could say, now we've got an implementation, we've got this implementation or that implementation of the interfaces. I haven't shown you a single class yet in any of these diagrams. But now I have to, because linked hash set and linked hash map are now enter into this. So this is the first time that's ever happened. But it was one of the most irritating things that drove them to introduce this. That drove them to introduce sequence collection was the inability to handle linked hash set and linked hash map properly. So that's how come that that's kind of the history. It's quite archaeological, the way the layers build up. There's difficulties with this. The APIs become quite untidy, I'll give you an example of that in a minute. If we just look very briefly at the interfaces, they aren't. They're kind of obvious from what I've said. There's a new method of sequenced collection. This is at the highest level. Any sequenced collection has got a reversed method on it, and it's got 6 methods, 3 for each end, and these are adding, removing, and inspecting. So it's not difficult to remember. And just in the same way, a set adds no operations to the collection interface, but gives it a special semantics because you can't add a duplicate into a set. In the same kind of way, the reversed operation overrides the reversed operation of sequence collection because, and this is kind of really invaluable thing now, we have covariant covariant overrides. We've had them for a long time, but you see them really coming into their own here, where you can actually return a subtype of the return type of the method you're inheriting. So reversed on collection returns a sequence collection, but reversed on a sequence set returns a sequence set. So if you want to look, so for example, if you want to inspect to iterate over a linked hash set in reversed mode, then you can do that, and you still know that it's a set. It doesn't have to get upcast into being a sequence collection. So that's a benefit. And it was really for linked hash set that interface was introduced. And sequenced map is again the same kind of thing. There are new methods which do something fairly obvious, I think, in most cases. That you can get a reverse. Remember, so a sequenced map is one in which the keys are in a strict total order. So you can reverse that order if you want to iterate over it. You can get back a sequenced key set, which is a view, obviously, of the kind I talked before. Sequence value, sequence entry set. These are views that just exactly correspond to what you get on unsequenced ones. And there's a put first and put last for symmetry, even though, of course, most implementations of sequenced map in the platform at the moment are internally ordered, and so these things will, guess what, throw unsupported operation exception. And we've got some methods promoted from Navigable Map, because Navigable Map and DEC were pretty near to already having the full set of operations that sequence collection we're going to have, and so there was a big issue about naming. So the names that we've got aren't necessarily very tidy. This is just, I've had to kind of think of the correspondence between the names with which things were already done and what has happened now. They've been retrofitted to the sequence collections API. So, for example, Navigable Set has got a method called first. But now, because sequence collection, there has to be some name that everything's going to have, has a get first method. We now have two methods that do the same thing, first and get first, and last and get last, pull first and pull last. And we've got two unsupported methods for obviously add first and add last, because Navigable Set is internally ordered, and you've got what they used to call descending set, and of course it's still there for compatibility reasons. Is now reversed as well. So now when you look at these interfaces, you think, right, Audrey's going to think, really, WTF? Like, there's a lot of methods on there, and quite a lot of them do the same thing. Honestly, Audrey, you just pay attention. So the issue is, for complex software like the Collections API, you've got 3 things that you want. You need to be able to develop it incrementally, because we know that software that isn't developed incrementally never actually gets shipped. right? You try and do big things and you say, well, I'm going to get it absolutely right first time. And you know that doesn't work. So there's many projects that have failed spectacularly in that way. So assuming you've got to have incremental development, then you've got a choice between a clean API and backward compatibility. We've got all these methods in there because we want backward compatibility. And Java always values backward compatibility above everything, pretty much. So that's how we end up. And there are other issues as well. The different collections have different policies about what to do if things go wrong. Sometimes they return null. Sometimes they throw exceptions. And there's different conventions about these things. And they're not going to marry up everywhere. You've got to make a choice. When you retrofit a new interface like sequence collection, there's going to be lumps and warts on the thing. Right, are you happy now?
Almost. Well, I mean, if you know so much about collection, would you mind at least giving me some useful piece of information about the collections? Like, I don't know, how to use them.
Are you seriously implying I haven't said anything useful at all today? You are, aren't you? I told you. She's really fulfilling my demand to be annoying. Do something useful at last. So, what have we got? Well, I mean, luckily or unluckily, I'm down to 7 minutes. So this is going to be a fairly quick-fire set of things to do, and you either explain them in a lot of detail or you don't. So. Some guidance for using the Java Collections Framework. I'm going to put a chapter. This is some of the points from the chapter that I'm now writing to put into the book, because this seems to be quite a. There's now quite a lot of knowledge. In some ways, it's the most useful thing that anybody can say of the 15 years since the book was published and the 25 years that the Collections API has been around. And my technical editor is Stuart Marks, who leads the team at. That looks after the Collections Framework, amongst other things, and so he's the main designer on sequence collections, and so he's seeing a lot of the bad practices that people are using with collections generally, and I'm going to try and get some guidance into the book, really guided by him, I suppose. So the first one is a concept of ownership, like. If you, and this is something to think about if you're a library writer or if you're writing client code. Do you own this collection in the sense that the values in it are important to you, as they form part of your state? And if they do, then that boundary should be well defined as to where the ownership lies. I mean, closely collaborating classes can regard that they've got joint ownership. But if you've got some public API and you don't know what's happening on the other side of it, then in principle, if you're a client and you get given back a collection, you don't own that collection, and you should regard it as a read-only. Thing. So this is kind of general guidance, but the concept of ownership of a collection, which is not actually formalized anywhere in the semantics of them, is actually really, I think it's quite a useful idea, and I want to try to explore that a bit in the book. Use records. So a lot of the bad practices that people have had with like parallel lists where you've got corresponding values and you step through each list in parallel. Records are just going to be wonderful for getting rid of all of that sort of thing. And similarly, people have often used lists as a kind of ersatz, substitute records, where like the first element is you've got a heterogeneous list, and the first element is I don't know, essentially like a 3-element list would be like a triple. And you're going to distinguish the individual elements just by the index in the list. Now that's a perfect situation for using records. So don't use lists anymore for that. If you're customizing a collection, you've got something you want to be an array list, but array list doesn't do things quite right for you, then there was a very clear intention written into the original Collections API, which was we've got these abstract collections which you're not really meant to know about unless you have a new collection that you want to write. And so array list, for example. inherits from abstract list. And so should you if you want to customize a collection. So what you can do is you can inherit from abstract list and you can delegate operation. You don't have to do all the work. You can have your customized list, inherit from abstract list, and contain an array list, but delegate to it and modify its operations. Don't use legacy collections, don't use synchronized wrappers, and don't use linked list. Don't ever use linked list. That's the single most valuable piece of guidance about linked list. And, okay, so I've got 2 minutes left, but I wasn't going to talk a lot about these things. You've got to choose the right abstraction to if you're crossing an API in particular, this is advice for library writers, what are you going to give people back? If you give them back an iterable or an iterator as a return value, then there's a very limited amount of things that they can do with it. A collection is something that's actually a bit lower in the hierarchy. A collection or a stream is going to give them much more scope to be able to do things with. Program to the most general interface that makes sense. People really know about that. Typically, you'll give people a collection, or rather, you'll accept, for library writers, accept a collection if you don't actually need it to be a list or a set. And then you're giving your clients the most scope that they can, the most scope that you can to for whatever they want to do. You're not confining them to one particular place, to one particular type. Don't store null in collections. Just a generally good idea. The libraries are moving further and further away from accepting nulls. So we get more and more null hostile collections. And generally speaking, null is more useful as a special return value to say that you didn't get an element. You were looking for an element, but you didn't get one. And so collections that can do that generally don't store null. And that's it's a much cleaner way of doing things. Prefer immutable objects as set or map keys. Don't mutate set and map keys. Don't ever do that, because if you do that, I mean, this is good. I'm mixing, these are mixtures of kind of quite high-level things and things you really should know anyway. Like, you're not going to do that, are you? Because if you mutate, for example, a map key, then it's entirely likely that when you come looking for it again, you'll just never be able to find it. And in the same kind of way, obviously, override hash code if you're overriding equals. Define compare and compare to be compatible with equals. In other words, make sure that two elements compare as equal if the equals method lets them compare, and then you can use them in sorted sets and navigable sets without losing them, which happens otherwise because they look like duplicates. And don't worry about pre-sizing unless you know that resizing is a performance problem, because it's often a lot less of one than you think. I mean, generally speaking, the collections just work, so don't worry about that. And the most important advice of all: buy this book, because it'll have all that in there. Thank you.
So the key question is your assistant happen now?
Are you satisfied now?
Week top 5. Questions?
With these changes in the collections framework, are any of those for value types that are coming down the road?
What is going to be the effect of value types on the collections framework? Yeah. That's a really interesting question, and that may be, so that's probably a subject for the 3rd edition. To be honest, I'm very interested in value types, but I haven't thought about the consequences for collections. I think in the first place, probably not a lot, but I think they'll be able to get leverage from them. And I think we will see interesting things happen, but I can't tell you anything in detail, I'm afraid.
Thank you very much for this talk. It was really interesting to see the past and get a glimpse of the future as well. My question for you is, in the Java ecosystem, you have quite a number of different collections frameworks, say Eclipse collections, Guava, the standard JDK collections as well. In your personal opinion, do we really need that many of them, or are we going to a world where everything is going to converge into what the standard JDK provides, and all of them will be phased out?
I don't think that. No, they won't. No, they won't converge. I mean, they have different design aims. I mean, you're looking for. So they're incompatible. I think would be the short answer. So we're not going to see any convergence. You would the people who designed these had different ideas. So to take an example, the Eclipse collections, which are very nice, and if you once you get into them, you can do a huge amount with them. They're going to be for different people. Effectively, I mean, you're not going to get your head around Eclipse collections without taking some time to do it. And if you're an ordinary Java programmer and collections aren't that important to you, basically you don't want a lot more than an array list and hash set, then you're not really going to want immutable bags. And you're not going to get into Eclipse collections unless you do want. If you do want those things, then they're fine. I mean, Kotlin's obviously a case on the side. Guava collections, well, they have a very if immutability. I mean, Guava collections are nearest to being really immutable. So if that's important to you, or unmodifiable, we have unmodifiable things in the collections API. I haven't talked about those. The Java 9 collections, list.of and map.of and so forth. But the ones in Guava are much more advanced. So if that's important to you, you'll use that collections library. So it's horses for courses.
Thank you. Questions?
Maybe I missed it, but that reversed method on sequence collection, does it return a view on the original collection or an independently modifiable collection?
Sorry, I didn't catch the first part of what you said.
The reversed method on a sequenced collection, does it return an independently modifiable collection or a view on the original one?
All right. So reverse. So the question is, what would the kind of view that you get back from the reverse method? What's that going to give you in terms of transparency? If you like, what operations will actually work through to the underlying backing collection? And the answer is that let me think about it. I mean, for things like deck and navigable set, there's not a problem. For things like for a hash set, a linked hash set, that is transparent. So you can actually put something into a particular place in a linked hash set using via the reversed reversed view. I can't remember about others, but I think mostly the aim has been to make them as transparent as possible. These views that don't, I mean, the way I explained it, I hope you see that the views often can't be fully transparent. You can't delegate all of the operations on a view through to the backing collection. But in general, that's kind of awkward and painful. And once again, it's like, where's the substitution principle gone because of these optional operations? We'd like to avoid that if we can. So I can't remember in detail what all of them do, but most of them will do, yeah.
If you modify, will the modification be reflected in your original collection?
That's what I was answering.
Okay, yeah.
Yeah.
Questions? Oh, I see a hand.
In the guidance, there was one point related to not using linked list. Can you please emphasize a bit on that?
I'm sorry, I didn't catch that.
In the guidance, one of the point was don't use linked list.
Yeah.
Can you emphasize a bit on that?
Yeah, linked list is a really terrible data structure, and probably the worst thing about it is the fact that it takes up a lot of space. And you think, well, that's okay because modern hardware has got lots of memory's cheap, but the problem with using up lots of space is that obviously there's a penalty in terms of garbage collection, which is quite big. But also linked list has very, very poor spatial locality. So values are scattered around different places in memory. And what that means is that every time you want to get a new element, you're going to have to you jump to somewhere else in memory. And typically that means a refresh of the entire cache structure. So your level 3 cache, your level 2 cache, and your level 1 cache, if that's the way your machine works, will have to be replaced. And that's very expensive. So iterating over a linked list just takes forever, mainly because of the spatial incoherence of the data. There's really not very many things. I always use linked lists as an example of a data structure where you can do certain operations in linear time. You know, like adding an element to the beginning of a linked list is a constant time operation, whereas adding an element to the beginning of an array list is order n, because you've got to shuffle all the elements up. But you can just link a new cell to a linked list. And I always like to use that as an example, but I can't really anymore because that one use case is completely outweighed by all the other use cases where it's really no use, really rubbish.
Okay, thank you. And we are running out of time, but you're welcome to come later and ask questions.
Sure.
I think. Thank you very much.